Alright, so in this video we're going to talk about parabolas. We're going to talk about the shape of them, we're going to talk about the transformations that we've done before, and kind of talk about another algebraic way of looking at these transformations. Okay, so let's start off with something simple. Let's start off with the function f of x is equal to, let's do x minus 2 squared, and then let's say minus 3. So this is a function, okay, this is going to definitely look like a parabola. Let's go back and think about what we talked about our transformations before. We definitely had an original, okay, so our original shape was kind of like the y equals x squared. We know this eventually will look similar to that parabola. That's the shape it's going to have. And then let's talk about the transformations that this had. Had a couple of different transformations. First of all, inside this parentheses, there's this minus 2. And as we've learned before, this is going to be a side-to-side shift. So I have a horizontal shift, and if you remember, inside the parentheses, you sort of want to think of it as opposite of intuition. So this says negative 2, which means the horizontal shift is actually to the right 2 units. Okay, and then my next transformation is this minus 3 outside the parentheses. Now that's going to be our vertical shift. So if I talked about a vertical shift, remember outside the parentheses sort of stayed with the intuition, so the negative really did mean down 3 units. Okay, so those were my different shifts. Now let's try to imagine that visually and see if we can make some more sense out of that. I'm going to actually go ahead and graph the original and then do the transformations. So let's go ahead and graph the original. Okay. All right, you know the original parabola certainly starts here at the origin. You can do some xy tables, etc., etc. But the parabola, the parabola looks something like this. That's my original y equals x squared. Okay. Now what I'm going to do is do the transformation next. So let's talk about that transformation. And now if we looked at the previous page here, I had two different transformations. First of all, horizontal shift to the right 2 units, and then a vertical shift down 3 units. So what I'm going to do is I'm going to talk about just this point that sits here on the origin, okay, that very bottommost or minimum point of my original parabola, kind of like the center point, easiest one to do the transformations for. And I'm going to do those 2 different transformations for it, to the right 2 units and then down 3 units. You're going to do each one of these. So I'm going to go to the right, to the right 2 units. So go over 2 units, and then I'm going to go down 3 units. All right, and that's going to be where my new point is. Okay. So I just went, oops, sorry about that. So I just went to the right 2 units, down 3 units, and then I'm going to redraw my parabola. Okay, again, it's probably not 100% perfect, but I'm going to redraw my parabola. So the idea here is what I have done is I have created the new parabola, the y equals x minus 2 squared minus 3. Let me write that a little bit clearer here in green. Y equals x minus 2 squared minus 3. This is my new parabola. Now notice this ordered pair, the point that we plotted, okay, that one point that we plotted, look at that ordered pair there. That ordered pair was, if you look at the ordered pair as the x comma y, it was 2 comma negative 3. Okay. What we call this is the vertex of a parabola. So the vertex of a parabola is that center of the parabola. What I want us to notice now is that 2 comma negative 3, those numbers actually came from those transformations. Okay. So let's go ahead and talk about that in a more general case. That's not just a fluke. That does in fact happen. So that's what, when you have a function written in this order, that's going to give you the vertex of the parabola. So I'm going to give you kind of a general situation. If I were to give you a function f of x equals to a times, and then let's call this x minus h squared minus k, plus k. Alright, this is sort of a general form of a parabola, where a could just be any number. Okay, a is that outside. That was when we talked about shrinks and stretches, that kind of thing. And then the h's and k's were our vertical shifts and horizontal shifts. Okay, what we're going to talk about then is the vertex of the parabola. So the vertex of this parabola is going to be an ordered pair. So the vertex of my parabola will be h, comma, k. Okay. Notice the difference. The h changed signs, the k did not. This was plus k, it stayed a positive k. This was negative h, it changed to a positive h. So just keeping that in mind, this is going to be the general case for the vertex of a parabola. Now the vertex of a parabola is going to be either the maximum or the minimum, okay, again depending on whether or not the parabola was flipped upside down or not. If it was flipped upside down, that vertex would obviously be the maximum. If it were flipped up, stayed right side up, then obviously that vertex would be the minimum. Those are your two different cases for the parabola.